The LPP models can be solved by a graphical method if two variables are presented in the model. If more variables are presented, then it is difficult to sketch the graph. That is why we will consider only two variables in this example. The general process to solve a LPP problem by graphical method are given in the 5 bullets. The first, graph the inequalities. The second, form the wall of region. The third, find the corner points. Fourth, test the corner points. And fifth, find the solution. In the simplex method, LPP models can be solved if two or more variables are presented in the model. The graphical method is very useful in lower dimensions. For example, if there are two variables. If we have more than two variables, then we are looking at some higher dimensional shape. Then we cannot interpret anything easily in three dimensions or higher dimensions visually. Therefore, the simplex method gives an algorithm for solving this problem with any number of variables. Please note that the simplex method can be applied to 2D, 3D or higher dimension with linear equations. In other words, simplex method can be used for theoretically unlimited amount of optimization variables. The process to solve a LPP model by simplex method are given in 6 bullets. The first, convert subjective function with less or equal to inequality. Number second, introduce select variables and convert inequality to equation. Number third, prepare simplex table. Number four, find pivot column, pivot row and pivot element. Number fifth, convert pivot element to 1 and else to 0. And number 6, if optimal solution is not achieved, iterate the process from 4 onwards. Similarly, the minimization model of LPP by simplex method can be done with the help of maximization model. For this, first of all, we will convert the subjective function of minimization model with greater than inequality, and then we will formulate dual problem with less than or equal to inequality, and then we will solve LPP with maximization model, and which will give the answer for the minimization model. Now, how do we execute the LPP? Let us see one example. In this example, the decision variables are x and y, where x represents the number of x pots and y represents the number of y pots. Then we will define the constants. Since the company cannot produce a negative number of pots, so x is greater or equal to 0 and y is greater or equal to 0 is considered as a constant. Then we will define subjective function. Given that each unit of x pot requires 300 unit of copper and 100 unit of steel. And similarly, each unit of Y pot requires 100 unit of copper and 200 unit of steel. And also, the company has a total of 5 kg of copper and 12 kg of steel. Therefore, the subjective functions will be 300x plus 100y is less or equal to 5000 and 100x plus 200y is less or equal to 12,000. Now we will define objective function. We know that we need to optimize the profit. On each sale, the company makes a profit of rupees 400 per unit x sold and rupees 500 per unit y sold. Therefore, the profit function is z equals to 400x plus 500y, which is the objective function. With this, now we can model our LPP problem. The model is maximize a function z equal to 400x plus 500y subject to 300x plus 100y is less or equal to 5000, 100x plus 200y is less or equal to 12,000, x is greater or equals to 0 and y is greater or equals to 0. So thank you very much watching this video. In the next video, I will separately discuss about the graphical method and simplex method to make a better understanding. Thank you.